Hello and welcome back. In this video, we will understand one more important concept of Java, which happens to be encapsulation. Directly by writing the code, I would like to explain this beautiful concept. To start with, as you can see on your screen, we have one class by the name student. Inside this, we do have one data member, one instance variable, which is age. Great. And I have created the instance of student. As you all know, that is an instance variable. If you don't assign any value inside that variable, by default, a default value would be assigned by JVM. So since it is of integer type, inside this age variable, JVM will assign default value at the time of object creation on your heap area. This we have understood in the concept of instance variable versus local variable. If you have not yet watched, please do watch that video. I have created the instance of a student class here. Great. I would like to print. I want to know what data is there inside that age variable. I can use a reference variable st dot age. You can see I can access this member of a class outside the class by using the reference variable. Even if I have to run this application, you can see on your screen, you are getting the output as 0. That is default value has been assigned. Can I assign the value? Yes, you can assign. I'll say here reference variable of this particular instance happens to be st. I will take it st dot age and I would like to assign the age. Maybe I'll say here age equals to maybe 18, 17, whatever you want, you can assign. After I have assigned, again I'm printing what data is there inside this variable. If I have to just run this application, you can see we are getting 18. So what I'm trying to say is, whenever you create a variable instance that can be accessed anywhere inside the class is what we have understood earlier. Right now, you can also notice here, we can access this data member of a class outside the class. This is a different class. This is a main class. This is a main method class. And this class is a different class. Outside the class also this data member can be accessed using the reference variable, and it is not good for the programming. What if someone accesses this age variable and assign whatever value they feel like? Maybe I'll assign some value here, minus 18. Integer value can be minus, there is no problem. It can be positive, it can be negative. There is no problem there. But however, logically, can the age of someone be minus 18? It is illogical data, right? That means there is no security to the data member of this class. Anyone outside the class can also access and assign whatever data they feel like, which is not good for the programming, which is not good here. So for which, what solution we do have? Whenever you create any of the data member, it should be accessible within the class itself. You should restrict the access of this data member from outside the class. That means outside the class, no one can access this data member directly. For which, what solution we have? We have to use one keyword which is supported by Java, which happens to be private keyword. The moment you say private, you can see I'm getting one compile time error here. We got compile time error. The field student age is not visible. That means this is restricted within the class. This data member can be accessible and can be visible within this class itself. Outside the class, no one can access, no one can even see. So even if you try to access, you can see here, we are getting the field age is not visible. What is age? I don't even know. So if you make a variable private, you are restricting the access and visibility of that variable within the class itself. There are other access specifiers which happens to be private, protected, default, and the public, which we will discuss separately going forward. We are going to start the concept of inheritance polymorphism. During that discussion, we will try to discuss in the on the 4 important access specifiers. For now, to start with, if you make the data member private, can you access that data member outside the class directly? The answer is no. We got here compile time error. Directly outside the class, you cannot access. However, if you don't make private to the instance variable outside the class, anyone can access this variable. They can get the data of this variable also. They can assign a new value also, as we have already seen. But the moment you made it private, no one can access. You have limited the visibility and accessibility of this variable to the class itself. Now the requirement is, maybe someone outside the scope of this class, someone outsider which is coding some other class, they may have to assign some data here. What to do? The moment you have made it private, no one can access it. So we have to do the arrangement. That means I'll be writing one method here. Whenever you have any activity, anything to be performed in a class, we go with the concept of methods. So let me write one method here. Maybe public, or what is public we have not yet discussed. Going forward I will discuss, so I don't want to use that. I would like to go here and say void, maybe I'll say here set age. Whenever you give a name to a method, as I have discussed earlier in the concept of methods also, whatever name you want you can give, there is no problem, but it is highly recommended and it is industry convention that give a name of a method based on what activity you are doing inside this method, whatever task, whatever code you are writing inside this method, right? Give a same name so that it will make a sense. By the name itself, anyone can understand that what activity might be happening inside this method. So what I'm going to do here is, I will say here int is a type of maybe x, and whatever I'll receive from the x, I would like to go here and assign back to a variable called as age. Great, fine. I would like to save this. And now from the outside the class, there is a requirement. I want to assign the value to it. Can I use a reference variable st.age? Can I say? No, we don't have the concept of age itself. I cannot say that. I'm getting compile time error because age is a private variable of this class. This can be accessed within this class. But do we have an option here? Yes, we do have an option. I will call the method. By the name itself, you can see how beautifully I have given the method name, set age. By the name itself, I can understand this method can be invoked to set the value to this age variable, right? So I'll say here dot set age, and I'll assign some age here. Maybe I'll assign the age as 18. It will be assigned. Fine. Now the requirement is, maybe outside the class, whatever data is there inside this variable in some other class, I want to access the data. Maybe I want to print from the main method. I want to print on my console that what data is there inside this variable. So can I do system.out.println and system.out.println? I will say here st.age. No, I cannot access the age because it is a private member. Do we have any arrangement? No. So I'll make one more arrangement here. If you know the concept of methods, what I'm going to do here is, I'll say here int is a type of get age. That means whatever data anyone wants, they can invoke this method. Inside this method, I'll write a logic which is responsible to return the data which is there inside this data member, inside this variable, right? If someone outside this class, if they want to access the data which is there inside this variable, can they call the variable name directly? The answer is no, because it is a private member. But do we have any arrangement? Yes, we do have an arrangement. So what I'm going to do right now is, I will say here student.getAge. By the name itself, I can understand if I invoke this method, it will give me a age, get age. See the naming I have done here, right? So if you want, you can collect it back in a variable, maybe integer type of age, and then you can print system.out.println age. Of course, I'll say here age. So what is the age I'm assigning here? I'm assigning 18. So when I get that age, of course, on your screen, it should be 18 only. You can see we are getting here 18, or directly also you can print. Both of them are same. If you know the concept of method, if you have watched the concepts of method, so you will not face any issue. st. I'll say here get age. And if I just have to print, it will give you the same result. Making sense? Now, a method which is responsible to set value to the data member of a class, to set value to the instance variable of the class. The whole purpose of this method, am I writing any other business logic here? No. The whole purpose of this variable is to receive the value from the outsider and to assign it to my data member instance variable. That is the purpose, right? I will receive the value, I'll assign this to it. This method, you can call it as setter. Setter is also a method. Based on the activity or a task that setter is carrying out, we call that as a setter. And what is a method here? This calls as getter. That means for outside world, someone outside the class, if they want to access the variable, for them it is a getter. For them, this method is giving them the value which is there inside the S. For me, it is a getter. So this method is called as getter. Setter and getter is methods only. However, based on the activity, based on the code or the purpose for which you have written that methods, we call it as setter and getter. This method whole purpose is to set the value to this variable. The whole purpose of this method is to get the value which is there inside this variable. Now, after I made it private, outside the class, no one can access directly. If you want to assign some value, you may have to call through the setter. If you want to get that value, if you want to get the data, you have to call through the getter. Fine. Now, even through the setter, can I assign the negative values here? Something wrong? Yes, you can do that. Then what security you're giving? It is a method. If you want, you can control, you can write other logic also. Maybe you can check if in case age is greater than 0. If age is greater than 0, then I will assign the age. Else, I will do something. I will say here, maybe the data is wrong. Please enter non-zero data or non-negative data. It is a method, right? After all, I can write the logic if you want. You can control the access. So anyone and everyone cannot access any or cannot assign any data they feel like. It's like providing security to the most important component of your class, which happens to be the data members. And if people want to access anything, if they want to assign the data to this data member of a class, if they want to get the data, they have to access through the setters and getter. Setter is to set the data, getter is to get the data. One problem here which you need to understand, that whenever you're trying to access, right, maybe I will just erase this and write st.set age. You can see here int is a type of X I'm getting. Int is a type of data I have to enter. I'm aware of this. What do you mean by X? I hope you're able to understand. Int is a type of data, right? I will enter some data. Logically can be age of this many years. It's not possible, right? So what to do? In that case, it is recommended to give the name of this variable as same for which you are receiving the data. I will write here age, right? Now, if I just have to call this method st.set age, you can see int is a type of age. At the time of calling this method, if I have to assign the data, I can get to know what type of data I may have to assign. I will assign logical data. Maybe I'll say here 24 or maybe 18, whatever you want. Making sense? I'll save this. Now the moment if I run this, we are getting 0. We are assigning 18, right? Why are we not getting? When I call the getter and print it, it is giving me 0. That means data has not assigned here. This problem is called as shadowing problem. Whenever a local variable and instance variable, both of them are of same name, it will result in ambiguity to the compiler, and compiler will not assign any value. Compiler has received the value here. It has gone down. It's like here also it's age, here also it's age. It will not be able to differentiate which is a local variable, which is an instance variable. This will also be considered as the local variable in that case. It will not be treated as instance variable. So compiler will not assign any value to it, for which you have to use one keyword called as this dot age. Now we need to understand about this keyword as well. Fine. So the moment you assign this here, I would like to say here, you can see we are getting 18. This holds the address of currently running object. What do you mean by that? You must be knowing it. Whenever you create a class, you can create any number of objects of the same class. There is no problem. Right now, how many objects I have created? Only one object. Maybe I'll give the name as student1. The object name is student1. That's the name I have given here. Can I create one more object? The answer is yes. I'll create here one more object. I'll say here student type of st2 equals to new student, and after which I'll say here st2 dot set the age. I'm calling the setter and assigning the data. Maybe I'll assign 19, right? And maybe I want to know the data. I'll say system dot out dot println. I'll say st2 dot get the age. It will give me the age. Let me add one differentiating line in between so that there is a differentiating factor. Great. I would like to save this. And if I just have to run this, you can see this is for the object 1. This is for the object 2. What happens behind the scene here? That is what you need to understand. Let me open the writer here, and here, please understand this very carefully. As you all know that for the object, memory will be allocated on the heap area. Everyone is aware of this. About this, we have discussed in detail in our previous lectures. If you have not yet watched, please consider watching that before watching this part of this encapsulation video. Great. You are creating two objects, right? We are creating two objects. Object number 1. Whenever you create the object, every object will have an address, hash code, which will give a uniqueness. It will give you the address of an object, like the way you have different address for different homes. On the same way, in your heap area, for every object, there will be a unique address. Fine. So I'll assume the address of this object is 1000, and for which you are creating the reference variable st1. So inside this st1, address of this object will be present. In other words, st1 is a reference variable referring to this object, and inside this object, inside this instance only, memory for age will be allocated. The initial default value for this will be 0, right? Great. And the moment you call the setter and you assign the value 18, that means you are calling this st1.setter you are calling. That means this setter is getting called for object number 1, st1. Great. And what will be assigned here? 18. And you're telling this dot age. So inside this variable, 18 will be assigned. Now, you need to understand this. This keyword will have the address of currently executing object, currently running object. So this dot age means this will have currently which object is running. Currently student 1 object is running, because you are telling here st1.setAge. That is, you are calling this method for which object? st1 object. That means object number 1. So currently which object is running, currently which object is executing? It is student 1 object. So st1.setAge means you are invoking this method for which object? Object number 1. And when this method gets called, inside this keyword, address of this currently executing object would be present. It is something like this, you can say here, and this will be referring to this. So if you say this dot age, that means age of this particular object which is getting executed currently. You have told st1.set, that means currently this object is getting executed. So this dot age means this object's age 18 will be added. Great. After which you are calling the getter and you are printing 18 printed on your screen. Then you are creating one more object. On your heap area, one more object will be created. Address of this object, I will make an assumption that it is 2000. And while creating the object, memory for instance variable has to get allocated. And for this age variable, memory will be allocated once again inside this object, because that is an instance variable. Default value will be assigned by JVM. Then you are creating one reference variable, st2. which is holding the address of this new object. In other words, this st2 is referring here. Great, fine. Now if I have to open and show you the code, after creating the object, what are you doing here? You created the object, age, memory will be allocated, default value is given, and then you're telling st2.setAge. That means you're calling this method once again. You're calling this method once again using the reference of st2. That means currently which object is getting executed? Is it st1 or st2? The st2. That means student 2 object is what currently getting executed. Fine. If you call this method, of course control would go here to this method. This dot age means currently which object is getting executed? It is student 2 object, because you're calling the set age method by using the reference of st2. Making sense? So what happens here? This will have a address of currently running object, which is this. So of course this will not be referring to this. This will start referring to this object. And for the second time when you told this dot age, so age for this will be allocated, not for this. So this will hold the address of currently running object. It will represent the currently executing object. Making sense? I hope you are able to understand, especially if you have watched the earlier videos, if you know the fundamentals. Fine. So encapsulation, we have different definitions. Providing security to the data member of a class. Yes, if you make private outside the class, directly people cannot access it. If you want to access through the setter, you have to assign the data. Through the getter, they have to get the data. Binding methods and the variables. All this setter, getter and this variable, they are working together. That definition is also correct. Providing the controlled access. That means outside of the class, you cannot access this variable directly, but there is a control access. If you want to assign the value through the setter, you have to assign. If you want to get the value through the getter, you have to get the value. That definition is also correct. All the definitions which you can see on your, on the internet are correct on the encapsulation. And how to achieve encapsulation? Through the private, setter and getter. Fine. Making a variable private, and if they want outside of the class, if someone want to assign, they can call a method whose whole duty is to receive the data and assign that to the data member is setter. The method whose whole purpose is to give this value which is there inside this variable to outside of the class, to the outsider. For me, it is a getter. That's a method which will give me the value which is there inside this, because directly I cannot access. It is a private. Fine. Through the private keyword setters and getters, I can achieve the encapsulation. More on this by default, you'll understand going forward. We are going to start with one more interesting concept, which happens to be the constructor. Lot about constructor you have to understand in the upcoming videos. Thank you so much for joining me in this video. Make sure to like the video. Also, you can follow me on my Instagram. You can find the ID here. You can also follow me on my LinkedIn. Thank you so much for joining me in this video. We'll meet again in the next video.